began to look at what I titled data visualization and interpretation. So what we were able to do was to see how we can import external source of data and extract the information that is relevant to a project that we may want to handle. So that was what we did, and we said we can as well generate our data also directly from MATLAB. Either we are generating it from MATLAB or from an external source. What we want to do with this topic is to be able to represent our data graphically. Okay. So today we look at how to plot data in MATLAB. So for you to be able to plot your data set, the first thing is that the data you are presenting, the coordinates, should be array that are similar. We have looked at vectors before now. We saw that we can have row vectors, we can have column vectors. So if you are presenting your data to MATLAB, if it's going to be row vector, both coordinates should be row vector. If it's going to be column vector, both should be column vector. Then another thing is that the size must be equal. Both coordinates should have the same size of data set. So if you want to plot lines, if you want to make a plot that involves line, the command is just straightforward. We use the function plot, P-L-O-T. You open the parentheses and you pass in the argument. How do you pass in the argument? Basically, you pass in what is supposed to be on your x coordinate first, followed by what is supposed to be on your y coordinate next, and you separate them with a comma. So once you do that, then you get your line plot. But of course, you need to create your array first. So let's try the example on the screen. We are told that we have x data set that start from 1 and x as 6 as on the board. Then we have y that has the element 3, minus 1, 2, 4, 5, 1. So we see that number 1, the number of elements that we are given, they are equal. 6 elements in x, 6 elements in y. So now it's not left to us to now create those array. If we are creating x as a row vector, then we need to create y also as a row vector. If we are creating x as a column vector, then y also has to be a column vector. So we've been given the components of x and y. So let's create those array first. You decide if you want it to be column or you want it to be row. So do that. Are you working on it? I've given you what to do. Create x variable, that's the member on the board, and create y. Anybody with that? You can use any approach that is convenient for you, either the shorthand method or the typical method. Okay, that's fine. So 3 minus 1, 2, 4, 5, 1. Okay, that's the array. Mine is in row format. Okay, so now to plot it, say x data first, y data first. The last time that we extracted age and income from our file, so we could have, and we created an array called age, another array called y, so it's called income. So we could have made a plot of them if we actually want to plot them. So if you have a file that you have your data set in, you can work on them as you wish. So this is what it's looking like. So that's just it. That's how to plot in MATLAB. It's not more than that. Okay. So you see that we supplied x and y, x before y. But if it's only one argument that you supply, maybe you supplied only your y data. So what it's going to do is that it's going to plot whatever you have supplied on the y coordinates, on the y-axis, and the x-axis is just going to be the number of elements. So if there are, in this case, there are 6 elements in it, so that means the first point is going to be 1, the second one is going to be 2, up to the last element. So it's just going to assume for you that you are trying to plot this value against the index of each of the elements that is in your array. So if I close this plot now, the one we made using the values of x and y, and I just say plot y. So now it's only one argument, so it's still going to plot it, and it's going to be using the index of the elements that are present. So can we try the second exercise? It says plot sin x on the interval 0, 2 pi. Can you do that? So what is that question asking us to do? What's the question asking us to do? Plot sin x on the interval 0, 2 pi. What does it mean to you? Yeah, we are looking at a sine graph. So how do we get that? Okay, so what would be the start point? Is there anything like a start point? Is there anything like an end point? Okay. Okay, so that means our sine x is a function of x, and x is going to range from 0 to 2 pi. So we've seen that when we were creating array, if you have range of data that you want to create, you know how to create that, right? So we are starting from 0, we are ending at 2 pi. So you create array x first. When you create array x, then you get your y. Y is equal to sine x. Then you make the plot. Can you do that? Really, Toby? So if we be using shortcuts, we said something that 0 to 2 pi. So how does he interpret it? How does MATLAB ordinarily interpret that? So what does it do? If I say I'm using shorthand method to create a range of data, and I say 0 to 2 pi as I have here, so what will it do with that information? What will be the interval? We said if you don't say anything else, if you don't put anything in between the start and the end point, it's just going to, by default, it's going to use interval of 1, 1. That was what we said. Okay. So even if you don't specify anything in between, it's just going to put 1, 1 for you. But if you have a particular interval in mind, you just put it in between the start and the end point. So let's try that and let's see what it looks like. So y is equal to sine of x. Then we want to make a plot. Right? So this is what it has returned, because it has used an interval of 1 in between and is returning that solution to us. But if you want it to look smoother, then you need to put in small interval in between. You have to dictate what the interval is going to be, and you dictate something that will make it look smoother. So let's say, for example, instead of what we have now, we can edit it and say in between, maybe we should have something like pi over 100. It wouldn't matter because you are not the one that is going to be writing the values, but it knows what the range is going to be. Then it's very advisable to suppress it so that your command window is not filled up. Then you get your y again. Y is still what it is. But you need to recompute it since you have changed the value of your x. So you need to recompute it so there is no confusion. Then you plot. So let's plot it and let's see the difference. So you see it's looking like what we would have expected, right? So if you are saying get me this range of data sets and you don't specify what the interval is going to be, it's going to use 1 for you. But you can always determine what it is by introducing the interval in between. Okay? So that's like an application of the previous lecture we had on array and matrices. Okay. So when you graph data sets, it is very useful to add necessary annotation so that anybody that picks it up knows what the information you are trying to convey. Some of the annotation you can include is the title of the graph. Then you can label the axis. So how do we put title on a plot? The syntax is very easy. You just call the command title, and inside that title you put the name or the title you want to actually place on your graph. However, you put it in quotation. If you want to add x-axis label or y-axis label, what you just need to do is to call the command x label for the x-axis and y label for the y-axis. So inside of that function, you put the name that you want that axis to bear, you put it inside quotation mark, and you issue the command, and that's it. So let's try and put labels, x-axis and y-axis label, on the plot we have just made. So we want to say x-axis is 0 to 2 pi. That's what we want to add to it, 0 to 2 pi. Then for the y-axis, we want to say this is sine of x. Now if you look at the syntax in my note, you see that that's text that you want to add as the label is inside quotation mark, and it says exactly what we want. You say x equals to 0 to 2, but before that pi there is a backslash. So that backslash is put there so that by the time the output comes out, instead of seeing pi, you will see the symbol pi. So that is what that backslash does in that context. So if you are calling a built-in constant, okay, and you want it to come out as the symbol, so if you put a backslash just before that built-in constant, you can expect that it's a symbol that will come out for you. So let's try it. Has anybody done it? So the title of the graph is plot of sine function. So title is the function to use. You open the parentheses. Inside the parentheses, you put that title that you want inside the quotation mark, and you issue the command. So let's see what our figure looks like now. So it's actually looking like what we want. You know, if we were using script for this, you know, we can publish it, right? Both the codes and all of the outcomes that we are having. So assuming we are using script and not using the command window, right, directly, if you now publish that particular script, all of the codes that I have written and the solutions will be published. Okay. So what have you noticed about the color of the outcomes that we have obtained in the plots so far? What's your observation? At least I think we have made about 3 or 4 plots this morning. So by default, the color of your graph is blue if you have only one plot. But you can decide what color it's going to be. If you are not comfortable with blue, you can decide what color it's going to be. So if you have more than one data set and the range of value are well compatible enough or reasonable enough for you to plot on a graph on the same axis, it's actually possible for you to plot pairs of data sets on the same axis. So in that wise, the color of your output is not going to be blue alone. MATLAB is going to differentiate each of the plots with different colors. So how do we plot pairs of data on the same axis? That's what we want to look at next. So I will show you two approaches to this. The first one is that you usually plot command for the first pair of data sets, X and Y. So once you are done, you tell MATLAB to hold on using the command hold on. So when you put it at the hold on mode, then you can plot as many pair that you want to plot. And when you are done plotting all of the graphs on that axis, you hold off. So when you hold off, it stops stacking them on the same axis. So it goes to the regular mode of one graph per axis. That's one way to it. The other way is that you just use one plot function. But inside that one plot function, you put in x, y, x, y, x, y until you are done inputting them. So whatsoever you put in it, MATLAB believes that the first one is x, the second one is y. That's a pair. Then the next one is x, the next one is y, another pair. Okay? So until it has done reading whatsoever you have supplied as an argument into the plot function. So let's look at what we have on the screen. It says that we should plot the three related functions of x in the same axis. The first one is y1 is equal to 2 cos x. The second one is y2 equals cos x, and the third one is y equals to 0.5 cos x. And it's telling you that the interval, the range of interval should be 0 is lesser than or equal to x, x is lesser than or equal to 2 pi. So that means x should not be lower than 0, it should not be greater than 2 pi. So can you do that? So like we said, the first thing is that you want to create array for x. But in creating that array, you want to put in mind that the outcome, I want it to be very smooth. I want it to look like the typical trig function. So that means you don't want the interval to just be 1, 1. You want something that will make it to have a smooth look. So that means you can put a reasonable interval in between the start and the end point, right? Then when you have your x, you create what your y1 is. They've told you is 2 cos x. You create your y2, which is 0.5, which is cos x, and you create your y3. So you can use either of the two approaches. It's still going to lead you to the same place. So do that. So I'm creating x now. X equals to 0. Let the interval be 0.01, and I'm ending it at 2 pi. So I don't want it littering my screen, so I'm going to suppress what the outcome is. Then I create my y1, which is a function of x, equals 2 multiplied by cosine of x. That 2 suppressed because it will be as long as my x, so I have to suppress that too. And this is my y2. And this is y3. So let's try with hold on and hold off first. and let's see what happens. So let's plot x and y1 first. Let's see the results, if it's ready. Yeah, the result is ready. This is the way it's looking like. But we are not done. So let's tell it to hold on. So it's holding on. So now let's plot the next one, which is x comma y2. So let's see what we have. Okay. You see the second one has been added to it and is differentiated by the column. Let's go for the third one. So we have the 3. We can add the labels. So we want to say on the x-axis, we want to say 0 is lesser than or equal to x, lesser than or equal to 2 pi. So that slash LEQ is going to generate the less than equal to sign. Okay. So we want to say on y-axis that this is cosine function. So this is the outcome. So let me clear what we have done, and let's use the second approach. We are still going to get to the same point. So let's create x. We have created our x. We need y1. y2, y3. So now let's create the plot now. So what we have done now is to create pairs. So x1, y1, x1, y2, x, y3. So if it's not x, y1 and all of that, if it's any other name, let's say I won't see it from that point. So let's say you didn't say x or y. If you say a, comma b, comma c, comma d, comma e, comma f, it's going to believe that a is supposed to be on your x-axis, b is supposed to be on Y, C is supposed to be on X axis, D is supposed to be on Y, E is supposed to be on X axis, F is supposed to be on Y, based on the arrangement. Okay? What did you plot? So it's giving you blank check. So go and use it to withdraw money. So anybody who has done this? Correct with it too. Anybody again with that issue? So what I will advise is that look at your input again. Look at your input again. One thing about something programming is that very little thing can make you sweat. So you just have to have an eagle eye to fish out what the error is. Anybody with a result like this? So you can add label like we have had it before now. Alright. So now that we have 3 graphs, it is reasonable to be able to differentiate between the 3 graphs. That which one is this, which one is this. So that is where legend comes in. So you can add legend that helps you differentiate that the one in blue is the curve for this, the one in red is the curve for this, and the one in perhaps orange is the curve for this. So what do you use? The function to use is legend. So the syntax is just similar to the syntax for label for type 2. Whatsoever name you want to call it has to be inside quotation. Then you are going to put it in the order in which you have supplied the pairs of data. Right? We started with x, y1. So y1 is 2 cos x, y2, which follows, is cos x, and y3 is 0.5 cos x. So that same order in which you passed in the data that was plotted is that same order that we use to pass the name of each of the curve using legend. So can you try that? So each of the names is going to have its own quotation, and you are going to separate them with a comma. Has anybody done that? So with the legend, anybody that picks this up knows that the blue curve is talking about 2 cos x. The red one is talking about cos x, and if it's orange, I think it's orange, is 0.5 cos x. So there are no doubts as to what it is. Hoping that the person that passed in the name for the legend has passed it in the right order. So we've seen that the curves were differentiated by their colors, right? Now, aside from colors, MATLAB uses the style of the line. It uses the style of the line and the marker to differentiate each of the curves. You can use that. Now, what we have here is all solid line. But it's possible to have what is not solid line. You can have dotted, you can have dash, you can have a mix of it. Then for the markers, you can also have a variety of it also. Then colors also, you can decide what the color is going to be. I think for those that have other classes, we should stop at this point so that we don't prevent them from doing what they need to do. So we start from here on Friday. Thank you.